we're trying to find an equation of a line which is called f of x, and it's parallel to this one, and it passes through this point here. So what we're going to have to do is look at the parallel equation. So if we have m1 times by m2, so these are gradients, that is equal to minus 1. So in the very first one, we had z of x had a gradient of 3, right? That 3x. So we can stick a 3 there. And we're trying to find the gradient of f of x here. So we'll just call it m, and it's equal to minus 1. Let's solve for that. So we'll divide both sides by 3, and we get m is equal to minus 1/3. All right, that's almost there, but the problem is that we're missing a plus c component. So we say that f of x is equal to mx plus c. Now we have the m. We say that is equal to minus 1 divided by 3x plus c. Now to get that, right, to get that value of c, we have to substitute in x is equal to 1 and y is equal to minus 2. And that comes from this thing here. So we say minus 2. Just to save space, I'll get it here. So we've got minus 2 times by 1. Okay, quickly rearranging for this, we can say that c, well, first of all, I start over here, so anything times by 1 is that. So we can say that c is equal to minus 2 plus 1/3. All right, now if you don't like fractions, well then what you can do here is say that the 2 is also divided by 1. Now, I'm going to do some fancy math shenanigans here, and I'm going to say that I'm going to times it by 1. Okay, but in this case, that 1 is a special one. It's 1 divided by 1. Now, if I've got a number, let's say 4 divided by 4, what does that equal to? Oh, that's equal to 1. It's equal to 1 divided by 1. So the funky number that I want is 3. I want to have 3 at the top and the bottom. So when we say, what's my common denominator? It would be 3. And so that would be equal to minus 6 plus 1 over 3 and over 3. And if they've got the same thing, right? If they've got the same divide by 3 or divide by 4, whatever it might be, we can merge them, okay? So we can merge them. We can say that this is equal to minus 6 plus 1. Okay, and the final answer is that c is equal to minus 5 divided by 3. So our final equation is that f of x is equal to minus 1/3 x minus 5 over 3. Lots of fractions. So now we need to plot this thing. And this was our original point here. Okay, that point 1 and minus 2. But to plot it, what we need to do is use this gradient m. Okay, m is equal to rise over run. Now, the interesting thing is that our m is a fraction. Our m is minus 1 divided by 3. So what it means is we have to run along 3. So let's choose like 3 points over. So 1, 2, 3. And then, so we run along by 3. And we have to rise by minus 1. So we rise by minus 1 there. And so that's our next point here. This point would be 4 and then minus 3. Okay, so now you get a ruler and you connect the dots. But what you have to do as well is you have to add arrows to your line. Okay, so the final equation would be something like this, where the purple line is the line of choice that we're drawing in here. Cool. So this is really 3 steps. Step number 1 is to use this equation here. Okay, so that is to say it's for perpendicular lines. So you might see this symbol. Maybe z of x is perpendicular to f of x. So perpendicular means like 90 degrees. And if we have a look down here, it might not exactly look like 90 degrees because our axis here is slightly distorted, where this guy here isn't the same length as this one, but there should be 90 degrees here. It's just that it's been stretched across. Next step, once we do that, we can solve for our value of m. We substitute our point in and we solve for that. So that was over here, this point here. This was step number 2. And then finally the plotting aspect of it. So there was this like m component. So we had to say if our m was a fraction, okay, in this case that minus 1 divided by 3, we'd have to run along by 3 before we can get another whole number. Now you could run along by 1, but it's really hard to find out like 0.3 of a cell here. It's really, really difficult. So I'd always recommend to run along by that divide by 3. And so that's what we did, and we got another whole number point, and then we could plot it. And don't forget to put in your arrows here.